Yeah, I'm Kishore, Ragi, I'm a postdoctoral researcher at Riga Technical University. And my topic is not much related to quantum or atomic or molecular spectroscopy or laser beams. Little bit different. My topic is on numerical modeling of ozone pollution in troposphere. And did you know that green infrastructure has some negative impacts on ozone pollution in the troposphere? Did you ever think that some kind of negative impacts are there with green infrastructure like forest? Then we have some emissions from transport. Those are there, and with my background in chemistry and atmospheric science, atmospheric research in PhD, we have developed one project for the Marie Curie Fellowship, but unfortunately it was not funded. And we have submitted that project to the Latvian University with the help of Dr. Arnolds. So,
No, it will.
yeah. We know that several benefits are there from urban forests, these are common benefits, and in terms of environment, economy, and health. I don't want to go much deeper into economic and health benefits, but I will talk a little bit about environmental benefits. Usually, urban forests do have they decrease air temperatures in urban areas, and that is one of the benefit. And the second one is that it reduces air pollution related to particulate pollution, and other one is to mitigate climate change through carbon sequestration. These are the benefits, but we will see some other things. If we see Riga has nearly 44% of urban area covered with the green infrastructure. Most of the forest is covered in the outskirts of the city, and these are some of the areas. The forests are situated in Riga city, and one of the importance of this urban forest is that it counteracts urban heat effect. Urban heat effect is nothing but urban areas do have hard surfaces, bigger buildings, so those have a lot of heat, so that temperatures are little bit higher than rural areas. So to counterattack, we can go for urban forests. Those urban forests can reduce the temperatures, and that is one of the positive thing. And also urban forests do have another effect in urban areas, that is a tropospheric ozone. It increases tropospheric ozone. If we see the chemistry of it, this nitrogen oxides come from mostly transport, and those react with biogenic emissions like these isoprene and some other terpenes, and even with other industrial volatile organic compounds also, they react in sunlight, and they form ozone. This way, ozone is formed in the troposphere, and there are two kinds of situation. One is a NOx limited situation, and one is a VOX limited situation. In NOx limited situation, most of the things are VOX, maybe from biogenic emissions or some others. But in compared to if we compare Riga, we have so much biogenic emission because most of the city is covered by forests. So this is a NOx limited situation. If we increase NOx levels with emissions from transport, that ozone increases drastically. In some other cities, like for example, Dubai, if you see, they have more NOx levels, but NOx levels are less. If we try to increase the forest in that area, ozone levels increases. That's a NOx limited situation. And we have done some observational analysis from data taken from official statistics of Latvia. We have taken data for the Riga and Liepāja because they have a similar similar forest covers, and we have seen temperatures are a little bit higher in summers in Riga and lesser in winter seasons. So this is just a comparative study, nothing more. And we also have done analysis on WOX and NOx, NOx and WOX levels. And if we see most of NOx levels are from transport, most of the more than 50% is from transport. But if we see methyl, non-methyl volatile organic compounds, those are nothing but biogenic emissions, and some other sources are also there. And these values are from other sources, other sectors, mostly forests, we can say, yeah, in case of Riga. And we have done some observational analysis of NOx and ozone levels. NOx levels in Riga, Ventspils, and Liepāja. Little bit increase is there in the case of Riga in the NOx levels, but if you see ozone levels drastically increased. This can show us that NOx limited condition, little bit of NOx levels are increasing, higher levels of ozone in Riga. It is not only thing, several other things will also be there, but this might be the reason. And to do that, we have to do numerical modeling, and this is a complete modeling setup. We use we know WRF, I think weather research and forecasting model. That there's a famous model everybody knows, I think, and that contains chemistry and meteorology. And we have found in the numerical modeling method some problems as well. So in the numerical model, we will take input, and these are outputs, and we can calculate only these things, and we miss these points. We miss these gaps in the numerical modeling. And if you want to go for higher resolution, we have to make it a finer domains like this. And presently we have a strategy that 1:3 ratio. Here, for example, 27 by 27 kilometer resolution. Here we take 9 by 9 kilometer resolution and a 3 kilometer resolution. And when we do these calculations, these gaps will be there. And when we go for this inner domain, we still have to get these values, but these values are not there. So we go for just interpolation, statistical interpolation. That is we may not get good results because this place may have some kind of mountain as well. You cannot get it with a statistical interpolation. So I have developed one method to fill up the gaps. That method is called contiguous and logical enhancement of atmospheric resolution. Before going for inner domain, we have to fill these gaps. To fill these gaps, I have developed that method. I did not publish, so I am not going too much deeper into that. We will fill those gaps first, and then go for a finer domain. In that way, we don't have any problem. Even if you go for higher resolution, we are going in a scientific way. Previously, we are filling the gaps with a statistical estimation that may not give exact or good results. So objectives of this project is objectives are measurement of biogenic emissions. We need a biogenic emissions. Biogenic emissions data inventory is not there. We just have to use numerical models, we don't know exactly. So we need to measure biogenic emissions and compare with the numerical estimations. So that is one of the objectives. And second one is a numerical experiments. Yeah, for air temperature is nothing but how much urban heat island is reducing with this forest tracks in Riga with a numerical model with what we have developed. And another one is the impact on ozone pollution. This ozone, as we have seen, NOx and VOx levels, how it changes with the perturbed urban forest. So if we change some urban areas in the forest area in urban, what happens to ozone? That is one of the sensitivity study, and also we do with the perturbed transport emissions. Like a vehicular emissions, mostly in a Riga we use diesel vehicles. So mostly those have NOx emissions. So we will make some scenarios, scenarios of emissions, and we see how it is affecting, how much it is affecting, so that we can make a policy advice for this transport emissions. We cannot change it. We have so many benefits, so we don't do that, but we can make a policy advices for this. And these are the experiments with those things only. And with this project, we have several impacts: environmental impacts, scientific impacts, and health impacts. Environmental impacts, if we see protection of biodiversity and mitigation of crop and forest damage, because ozone pollution has a problem for health and even crops and forests as well. And the scientific impacts, we can have a new modeling method, and we can make a biogenic emission data that is crucial for not only for us, for everybody, because biogenic emission data is not available. Only people depend on numerical estimations only. And we can make collaborations with the epidemiologists and some kind of projects we can make. These are the impacts. I think we have covered with this study. We can know how much urban heat island we can reduce with urban forests in Riga, and moreover, we can know how much ozone pollution is affecting with the forests and even with human transport emissions. That's what we can do in this project. And I want to thank Dr. Arnas for helping me for a long time on this, and the collaboration is still going on with that, and we will see how we are going to get funded for this project. Thank you.
Okay, thank you. So are there any questions? Okay, please.
So with your model, you see how a city forest can improve the climate, the pollutions in the city.
Yeah.
Yeah. And now my question is, can you see if you decide that a certain percentage of the city should be forested, whether there should be big patches or whether you should have strips, or does it matter how?
It matters. It matters. Yeah. If we want to go for a smaller track, we need to have a higher resolution modeling. I plan for 200-meter resolution, every point 200 meters. If we want to see a little bit, we have to go deeper, and maybe a 50-meter resolution. It means that computationally it is very intensive, and at this age it's not a problem. Yeah, we can go for 20-meter resolution also. The problem is that the problem with the method. Yeah, I have shown you that as you go finer, you have to do more interpolation. That's what we should not do. But that's why we have to fill those gaps and go. It's a computational intensive.
Yep.
Okay, several more questions. So,
So do you know how in Riga it is actually measuring this pollution? So I don't think there are so many sensors.
No, we don't have sensors here, maybe 10 to 12 stations are there, they just collect data, but yeah, for this numerical modeling, we don't take this station data, we have inventories, yeah, global inventories are there, we take those data, emission data, but unfortunately, that is not good resolution, it may be a 50-kilometer resolution or something. So we have to use that data to run the models. Unfortunately,
You need to fill a lot of gaps.
yeah, that's what we had to do.
Other question was from Jans.
I just
Comment.
wanted to ask, do you comparison your results with two official measurers? One is the CP monitoring station network, and another is LKMA monitoring stations network. They have a plethora of data about ozone.
Yeah, we have data, yeah, like 10 to 12 stations are there, they maintain ozone data. And our numerical data is huge, yeah, but we can compare whether our numerical data, if that the results are correct or not. So we just compare. If those station data and these are comparable, we can say that whatever we have done is okay. That way, yeah, still issues will be there in the numerical modeling in the present.
Okay, thank you for the presentation. Now it